The first reaction we're going to do is between sodium carbonate and hydrochloric acid. Notice the aqueous solutions. So we've got the sodium carbonate dissolved in water and the hydrochloric acid, so two colorless solutions. So I'm going to add one to the other and we'll see what happens. And if you notice, you should have seen bubbles that formed. There's no color change. I don't notice any temperature change, but we did see the bubbles form. So did a reaction occur? We would say yes. The next set of reagents we're going to use is potassium hydroxide and hydrochloric acid. Again, two clear solutions. One has a little bit of, I think, some settling out of the potassium hydroxide, but for the most part, colorless solutions. So I'm going to add one to the other. Saw a couple bubbles at the beginning, but if it's a gas being produced, those first few bubbles is just from mixing. Notice I don't see any bubbles forming. I don't see a color change. I don't see a precipitate formed. But it is a slight exothermic reaction, so it is a little bit warmer to the touch. So remember, if we notice a heat change, we need to record that as well. So since we did see a heat change, did a reaction occur, we would say yes. The third set of reagents is sodium carbonate and sodium chloride. Again, two colorless solutions that we're using. Two colorless solutions. And if you think about this, think about what a double replacement reaction is. Remember, we said double replacement is cation replacing cation, essentially. So since both of these compounds have the same cation, does it seem logical there should not be a reaction? So we'll mix these two together and see what happens. Couple bubbles just from mixing, but notice there is no color change, there is no precipitate formed. I do not notice a temperature change, so we would say no change. The next two reagents we're going to mix together is sodium iodide, which has the yellow tint to it, kind of a yellowish solution. And then we have the lead 2 nitrate, which is a colorless solution. So we're going to add one to the other and we'll see what happens. And if you notice, we've got a yellow precipitate that formed. I don't see any bubbles rising to the surface. I don't notice a temperature change, but I would make a note what color that precipitate is, which is yellow. When we let this sit, and we'll come back to this and take a look at it toward the end of the experiment, but just by gravity, all that solid will eventually go down to the bottom of the test tube, and what we should see above that is that what they refer to as the supernatant liquid. That term is in your lab book, and that supernatant liquid is that liquid that always rises above that precipitate. Did a reaction occur? We would say yes. Again, no heat change, no bubbles, but we did see formation of a precipitate, and again, yellow. The next set of reagents we're going to use is sodium sulfate and barium chloride, which are two colorless solutions. And notice what we formed there is a white precipitate. I didn't see any bubbles rising to the surface. I don't notice a temperature change, but we did form a white precipitate, and again, make sure you include the color of that in your observations. Did a reaction occur? We would say yes. The next set of reagents we're using is the sodium carbonate and the calcium chloride. Again, two colorless solutions. We will mix one to the other. And notice we're forming another white precipitate. This particular precipitate, if I compare it to the first one, almost looks more, I'm going to say like cotton. There is a little bit of a difference in the consistency of that precipitate compared to the one that we just formed. see a difference there. I didn't see any bubbles rising to the surface. I don't notice a temperature change, but again, we formed this white precipitate. Did a reaction occur? You would say yes. The next two solutions are for potassium hydroxide and magnesium nitrate, two colorless solutions. We'll add one to the other. And notice we did form a precipitate. This particular one almost looks like a gel formation to me. I don't see any bubbles rising to the surface. It may be likely there may be a bubble or two that's trapped in there just from mixing, but I'm not seeing any stream of bubbles rise to the surface. I don't notice a temperature change, but again, we did form a white precipitate. Set of reagents is copper 2 nitrate with sodium sulfate. Notice all of these color, or most of the solutions are colorless. We had a little bit of color with the sodium iodide, but the copper 2 nitrate, we always have that characteristic blue color for copper plus 2 ions. So I'm going to add one to the other. So just a bubble or two on mixing. Can I see through it? Yes. So no precipitate. I didn't see any bubbles. I didn't notice any temperature change. If anything, it may have gotten a little bit lighter in color. You can kind of see that. But is that indicative of a chemical change? No. So no chemical reaction for this one. And then the next one, we've got potassium bicarbonate and hydrochloric acid. So two colorless solutions. And if I add one to the other, and notice you'll see those bubbles rising to the surface. I can see through it, so no precipitate. I do not notice a temperature change, but you can see that steady stream of bubbles rising to the surface, so we formed a gas. So did a reaction occur? We would say yes. Last two chemicals to combine, two clear aqueous solutions, colorless solutions, are the strontium nitrate and the potassium iodate. And I'm going to mix these together. Now notice there doesn't appear to be any reaction. Your lab instructions will tell you that to wait maybe 5 or so minutes to see if a reaction occurs. What I want to do is to use a stirring rod to stir this and to see if I can facilitate that process that won't take 5 minutes. If you were doing this on your own, if a reaction didn't occur, you would want to give it some time. I know ahead of time which things are going to react and which ones don't, but if you don't, you always need to give it that extra time. So all I'm going to do is to take a stirring rod, and I'm just going to hold this, and I'm scratching the sides of the test tube. What I'm trying to do is to force those ions, because remember, they're all spread out in that solution. So what I'm trying to do is to force those ions to get together so that they can combine. And if you notice, now we have formed a white precipitate. I don't notice a temperature change. I don't see any bubbles rising to the surface. It may look more cloudy than actual solid, but if there is some solid, you can kind of, when I kind of stir this, you can certainly see the solid moving around there. So did a reaction occur? We would say yes. I just want to go back to these others that formed the solid. I just want you to see, here's a good example. This was number 5, which was the sodium sulfate barium chloride. Do you see how that it was all cloudy? We didn't really see maybe defined solid formation, but after it sit for a few minutes, notice by gravity, all that solid goes down to the bottom of the test tube. This liquid that's above it is that supernatant liquid that we were mentioning before. So there's that one. I want to go back to it's not completely colorless, but I think if you look down at the bottom, you can see where it's more concentrated in that solid. Again, when all the solid comes down to the bottom, that liquid above would be that supernatant liquid. And just let me look at maybe one more. hasn't settled yet, but I think you see the distance that it has traveled. Given time, they will all eventually fall down to the bottom. So again, at the end, we have to put these in appropriate waste containers and then clean up, and then experiment complete.